Hi everyone, we're Team 13. Our topic was additive manufacturing and biomedical applications. I'm Matthew Lawrence.
I'm Lundrigan.
I'm Kendel MacDonald.
I'm Marin.
To give everyone a general overview of what our team will be discussing today, the shown agenda will be followed. The team will start by addressing the necessary background information related to additive manufacturing in the biomedical field. We will then discuss the four main topics that we concentrated on in regards to 3D printing in the medical field, which includes surgical tools, biomodels, implants, and external prosthetics. After these main concepts are explored, the team will move into the probable future directions that additive manufacturing will take in the next 5 to 10 years. To conclude, the team will discuss some of what we will believe will be the future impacts on the industry that the advancements of additive manufacturing will have.
Additive manufacturing is commonly used to label the technologies that are capable of building 3D objects by adding layer by layer of material. Some of the materials that are commonly used in additive manufacturing in today's industry are plastic, metal, and concrete. The main technologies that use the term additive manufacturing include 3D printing, rapid prototyping, direct digital manufacturing, layered manufacturing, and additive fabrication. There are countless applications of the technology today. Some examples include a visualization tool in design, highly customized products for consumers and professionals, and production of small lots of production parts. It is common for additive manufacturing technologies to use the help of computer-aided design, which is a 3D modeling software. The technologies are able to read the data from the CAD file and use a layer upon layer process to fabricate the objects in 3D.
The first topic we're going to cover is biomodels. Biomodels give doctors and practitioners the ability to 3D print an exact replica of the patient's organ from an ultrasound, MRI, or CT scan. This helps the doctor make a better diagnosis and sometimes even change their original diagnosis based on information that can be better examined with the 3D model instead of the 2D scans. These 3D models are generated by a three-step process that can be seen on the image on the right that take a digital image and enables them to be printed. The first step of this process is image segmentation, where the image is broken down into multiple labeled regions indicating certain objects and boundaries. The second step is mesh refinement, and this basically entails repairing any errors that came from the segmentation and exporting processes. It also smooths the surface of the model and removes any unnecessary parts from the segmentation. The last step is the 3D printing, which can be split into three groups of additive manufacturing, which are extrusion printing, photopolymerization, and powder-based printing. The next topic we're covering is surgical tools. Additive manufacturing is being used to help doctors 3D print a wide variety of surgical instruments that are used to make their jobs faster and more cost efficient for the hospitals. Some examples of tools being used related to additive manufacturing is the handheld suture devices and a variety of 3D printed surgical tools. A new type of surgical instrument that is being produced with additive manufacturing is the prototype on the top called the suture. This handheld device is able to stitch up a wound in a fraction of a time than a professional surgeon could. The small gears and rollers are all 3D printed and it only takes about 3 to 4 hours for each prototype to be completely finished. The benefits of this device are that it is affordable, time-saving, and easily operated with even minimal experience. The photo on the bottom contains several prototypes that are being researched to be printed and used in long-term space missions. A major conflict with bringing up extra medical supplies on a space mission is a limited amount of free space in the shuttle. The solution created for that problem is bringing a custom-built fused disposition modeling printer on the shuttle. This would give the astronauts the ability to print off any surgical instruments they need, along with printing off a variety of parts they could use on their missions.
Another topic that our team covered in our research on additive manufacturing in the biomedical fields is implants. One of the main purposes of additive manufacturing in the medical field today is that it has the potential of fabricating customized fixtures and implants. With the help of softwares like computer-aided design, commonly known as CAD, it is possible to manufacture customized implants using additive manufacturing that are specific to a patient's requirements. With the improved computer tomography, in the past years, it is now capable of obtaining extremely accurate information from a patient, which in turn allows for implants to be designed using patient's anatomy, injury type, or surgical technique. Some of the major benefits of using customized implants include the ability of the design being adapted to the patient's anatomy and pathology. Using customizable implants also diminishes the stress shielding effect and avoids the need of manual adjustment of standard implant during surgery. Additive manufacturing has also had a major influence in the ability of developing external prosthetics that is used by over 30 million people each year. Many manufacturers that don't use additive manufacturing have created a few model fits all approach. In the case, the manufacturer will create several different standardized sizes with neutral appearances. This means that the individual's requirements are not exactly met and the prosthetic is chosen from which standard size will fit best. With the use of additive manufacturing, the prosthetics can be custom made to suit the patient's needs exactly and at a lower price of the standard few models fits all approach. With the prosthetic being custom made, it will allow for more comfort for the patient as standard sizes usually cause stress on the body, which can become uncomfortable and sometimes painful to the patient. The use of standard few sizes fits all approach is also rarely aesthetically pleasing. It is nearly impossible to find a standard size prosthetic that is symmetrical between the body parts. Generally, people who have prosthetic devices want them to look as natural as possible, and with additive manufacturing, this is possible to achieve. 3D printing uses processes that are currently well established and fairly easily accessible. With this being the case, additive manufacturing is considered to be a low-cost solution compared to all other methods for manufacturing external prosthetics.
The team also concentrated on the future directions of additive manufacturing in the medical field. For example, 3D printing can be used to print personalized drugs for people. The idea is to have pharmacies fitted with these 3D printers that are able to print medications with multiple active ingredients and with very good accuracy. This means that pharmacists will be able to change a person's medications on the spot if needed, and also the accuracy of the machines will benefit people with medications that have small effective dose tolerances. Bioprinting is a major topic when talking about the future of the biomedical industry. The basic idea of bioprinting is that the technology of regular 3D printing is taken, but instead of the printer using metals or plastics as the extrude, the bioprinter uses living human cells printed out layer by layer to make human tissue. This technology may allow us, in the future, to be able to print human hearts, kidneys, lungs, etc. with the same DNA as the person receiving them. Through the use of bioprinting, bone meshes are also able to be produced. These bone meshes can replace segments of bone while containing stem cell stimulating chemicals in them that allow for the growth of joints, ligaments, and tissues around them. In terms of the direct operations in the medical field, in situ bioprinting may allow doctors to apply cells to a person's wounds either after surgery or in an emergency that drastically decrease the healing time of the wound. Although this technology has the potential to change the medical industry for the better, there are a few concerns for the future. One of these concerns is the possible hindrance of 3D printing technology due to bans. The reason for these possible bans are because 3D printing technology can be used for illegal activities such as making guns and ATM skimmers. If the 3D printing technology gets banned or limited, the research into medical applications can also be hindered as well. Another concern could possibly be getting over the regulatory obstacles that come with these devices. If the regulations are unable to be met, this technology will never become overly relevant. Although these obstacles are a real concern, it is likely that in the next decade, the medical industry will be utilizing 3D technology for many applications.
Seeing that additive manufacturing has recently become more popular, it is safe to say that as improvements are made and it becomes more common, the process itself will eventually become more cost efficient. Therefore, the growth in its usage in this industry will increase over the years to come. It's been noted that doctors can use 3D printers to make more practical models of patients' organs, which will allow for them to make better assessments and diagnostics. This will increase the efficiency and the reliability of our medical professionals, as well as increase the overall efficiency of medical facilities. In addition to printing more effective models, the printing of live organs, bioprinting, is also a research in progress. In due time, with the existence of a fully functional and reliable bioprinter, the number of organ donors as well as waitlisters to receive organs will reduce greatly, which benefits not only society, but also creates more space in medical facilities.
To give you some highlights of what was discussed, it was determined that additive manufacturing is technology used to build 3D objects. Biomodels have the benefit of producing exact replicas of organs. Surgical tools are used in remote areas and are more efficient. Implants and prosthetics are able to be customized to the patient's needs, In terms of the future, additive manufacturing will have continuous improvement, which in turn will improve the efficiency and reliability in the medical field. That's all from us. Thank you for listening.